Today's video is on the trigonometric functions of sine and cosine. So you are going to be able to identify the exact value of the coordinates of any angles using the unit circle in terms of sine and cosine. So let's talk about what we know about sine and cosine, and then we're going to talk about looking at it just a little bit different. So we know that sine is opposite over hypotenuse. We also know that when we took that reference triangle, remember this is the reference angle right here, and we put that on the unit circle, we learned that the distance that we go over is represented by x, and the distance we go up is represented by the y. And that gave us our coordinates of x comma y. We also know we have a radius on the unit circle that's equal to 1. So if we go from theta right here and we do the opposite over hypotenuse, the opposite is the y and the hypotenuse is equal to 1. And if we simplify this, this is equal to y. Now let's do the same thing with cosine. Cosine we know is adjacent over hypotenuse. So the adjacent here is the x. And again, the hypotenuse is a 1. So the cosine is represented by x. We're going to talk about tangent later, so I'm going to skip that one for now. So what we know is this. We know that the sine of theta on the unit circle is equivalent to y. The cosine of theta on the unit circle is equal to x. So instead of writing this as x comma y, we could also write this as, well, x is cosine, so we could write it as the cosine, and y is sine, so we could write it as an ordered pair of cosine, comma, sine. Put 2 commas in there. So we are going to start thinking about, when we're using the unit circle, that our x values are the cosines and the y values are the sines. So cosine, comma, sine is our ordered pair. So what that means on the unit circle is this. If I'm asking you the sine of, I'm going to write it off to the side here, sine of pi over 6. What it means is this. You know that sine represents the y. So what I'm looking for is the y value at the theta value of pi over 6. So you are now going to find where theta is equal to pi over 6. And that's right here. And you are then going to determine what the y value is at the point, which is 1/2. So if I ask you the sine of pi over 6, you are going to tell me it is 1/2. And that's what we're going to practice doing throughout this video. Here's just a few examples here. I have the sine of 30 degrees. This is the only one that's in degrees. We know that from here to here that this is 30 degrees. So I'm asking you, what is the y value at 30 degrees? So you will go right here and you will find the y value and you will tell me it's 1/2. Now the rest are going to be in radians. If you look at the next one, it says pi over 4. So you need to know where pi over 4 is. Pi over 4 is always the middle mark. Everything over 4 is always the halfway point. So now we're going to look at our y value at pi over 4, and that is square root of 2 over 2. The last one is pi over 3. So you must know that pi over 3 is the third tick mark right here. Here's our pi over 3. We want the y value because it's sine, so it's square root of 3 over 2 right here. And cosine works the same way. So cosine, though, is now the x value. So you're going to say, okay, I'm looking for the x value at pi over 6. So you will go to pi over 6, you will find the x value, and that's going to be the answer. Pi over 4, again, you must know that is the middle line right here. So at pi over 4, you will find the x value, which is square root of 2 over 2. And at pi over 3, that is the third tick mark. At pi over 3, from here to here, you want the x value, which is 1/2, right here. Now, those were all in the first quadrant. Now, what we're going to do is we're going to find the exact values of different marks throughout the unit circle. Now, for right now, you can have your unit circle in front of you so that you can see how these values are created. Eventually, we're going to do it without the unit circle, but today we will use it. So the first one says, what is the sine of 4 pi over 3? So my theta is 4 pi over 3. So I'm going to find 4 pi over 3 on my unit circle, and it is right here. And pretty soon, you got to be able to get used to where these locations are. Remember, the pi over 3s are the ones that can be reduced, the ones that are closest right here to your y-axis. And then you know that sine represents the y value, so you're going to find the y value right here, and you'll write down that value, negative square root of 3 over 2. The next one is asking for the x value at 4 pi over 3. So I'm at the same point, but now I want the x value. So it's negative 1/2. Now, when you have a negative value right here, you have a couple of things you can do, and we've talked about them. The first thing you can do is you can take and make that positive. So you can take and add 2 pi, and 2 pi is the same as adding 6 pi over 3, because we need a common denominator. And when I add the top, you can see what I'm going to get is 2 pi over 3. So the first thing I can do is I can go and find the y value at 2 pi over 3. And 2 pi over 3 is right here, and my y value is right here, so it's square root of 3 over 2. The next thing you could do is you could find positive 4 pi over 3 and then reflect it up. So positive 4 pi over 3 is right here. You could reflect it above the x-axis right here, and you would get to 2 pi over 3. If you flip this point up, this point up here, it would land on this point right here. And the x value, same thing, you could find it the same way. So I'm looking at the x value at this point, which is negative 1/2. And what I want you to be able to identify or notice right here is that when we had the 4 pi over 3 and the negative 4 pi over 3, we're looking for the x values for both, and both of them are over 3. And you're going to notice we have the same numbers. The signs may not necessarily correspond though. It does in that one, but it does not in the sine. This one is the y value of over 3, the y value of over 3, and look at that. You have the same answers, except for the signs are different. We're going to use that idea later, so I just wanted to point that out to you. Just a reminder, positive and negative angles. Positive angles go counterclockwise. A negative angle right here goes clockwise. Just a quick reminder. And again, we can take and add 2 pi or 360 to get to where we would be, or you can just go backwards, or you can find the original one and then just reflect it across the x-axis. So the 3 ways you can find the negative angles. All right, a bunch of practice here, and you can feel free to work ahead with any of these. So the first one, we want sine when theta is equal to 11 pi over 6. So we're going to go to 11 pi over 6, which is right here. And because we have the sine, we know that's the y value. So I want the y value, and it is negative 1/2. If I go across, we're still at 11 pi over 6, but this time I want the x value. And the x value there is right here, square root of 3 over 2. I'm going to stick with my positives, and I'll work with my negatives later. So I'm going to kind of jump around here. I'm going to go to this one, 7 pi over 6. If theta is 7 pi over 6, here's where 7 pi over 6 is. It's slightly beyond pi. And I'm looking for the x value right there, and my x value is negative square root of 3 over 2. The reason it's x is because it's cosine. If I look at this next one, I want to go to 5 pi over 4. The pi over 4s are the ones that are in the middle right here. And I'm slightly over 1, so I'm sitting here in the fourth quadrant. I want the y value. Here's my 5 pi over 4. Here's my y value. It's negative square root of 2 over 2. Doing the last positive one right here, I'm going to go to 5 pi over 3. Remember, the pi over 3s are the ones that can reduce that are close to the y-axis here. And at 5 pi over 3, it's right here. Because it's sine, it's the y value, and that's going to then give me negative square root of 3 over 2. Now again, with my negative values, I have the option. I can add 2 pi to all of them to get the coterminal angle. So if I add 2 pi to this, I'm really adding 6 pi over 3. So that's giving me 4 pi over 3. 4 pi over 3 is coterminal with negative 2 pi over 3. So when I go to 4 pi over 3, I'm right here. And when I pull the y value off, I get negative square root of 3 over 2. Right here. The next negative one, again, if I find the coterminal angle by adding 2 pi is the same as 12 pi over 6 because I need a common denominator. That is the same as 7 pi over 6, and I want the y value there. 7 pi over 6 is right here, and my y value is negative 1/2. So negative 1/2 is my answer there. The last one that I have, negative pi over 6. Again, I can add 2 pi to that. That would bring me at 11 pi over 6. Again, I also emphasize, instead of going to positive pi over 6, you go backwards, and I would find the negative value right there. Or I can go to the positive one, reflect it across the x-axis to get here, and what I would get is square root of 3 over 2. So there's a bunch of practice problems. Hopefully that makes sense to you. And with that, your assignment is to complete the exact value of sine cosine worksheet. There is a partial worked out answer key on Schoology, but you can feel free to, well, you can check all your answers with your unit circle. If you have any questions, let me know, or else you can also look them up online to make sure that you do have the correct answers. Have a great day. Bye.